Okay, looks like it's time to get started. Thank you, everyone, for joining our live lecture today. My name is Isaac, and I'll be the lead instructor for the lecture. And today's topic is going to be Front-End Frameworks in Angular Part 1. So what that means is this lecture will cover the first half of the Angular curriculum. So if you're in that section, this is the lecture for you. A couple things to mention before we get started today. The first one being is we're going to stop periodically throughout this lecture to open the floor for questions. So if you do have questions come up along the way, we just ask that you wait until those designated times to ask them. Another thing to mention is that we're recording this lecture. So at the end here, we're going to be posting on our YouTube channel, and we'll make that link available to you in your student dashboard. So diving right in, let's go ahead and discuss what topics we'll be learning about today. And there's two primary topics we'll be focusing on, and that is TypeScript and Angular. So let's first reference the documentation for TypeScript. Okay, and we can find that by going to typescriptlang.org. So TypeScript is what's called a superset of JavaScript, okay? And what that does is it adds additional features to the already existing language. Okay, and then we're going to be using Angular as our client-side JavaScript framework. Okay, so a framework is something that provides a bunch of out-of-the-box features as well as enforces a design pattern. Okay, so design pattern helps our application scale because otherwise we'd just be putting all of our logic into one single file, and that wouldn't make very much sense. So to get started, let's go ahead and learn how we can run TypeScript. Okay, so I'm going to go ahead and I'm going to create a base project on my desktop. I'll call it my TS app. Okay, and then let's open up the TS app inside of our text editor. Okay, TS app for TypeScript. Okay, so first thing we're going to need for this application is a TypeScript file. Okay, so for your machine to be able to run TypeScript, you're going to need to install it. Okay, and as you can see here, they give you the option to download. Okay, so after it's downloaded, we can start by creating a TS file. I'll just call it app.ts. Okay. Then we can go ahead and we can write some JavaScript code in here. Okay, so I'm just going to put a simple console log right now. I'll say hello world. Okay, we'll save all, and then what I need to do is I need to compile this. Okay, because the browser doesn't understand TypeScript; it only understands JavaScript. So the idea is we write it in a TypeScript file and compile it down to a JavaScript file. So to do this, we're going to use the command tsc. And then I'm going to target app.ts. Okay, as we can see, it produced a JavaScript file. Okay, so now we have this to link. Let's go ahead and create an HTML doc. We'll set up a basic HTML skeleton. And then put simple body, world for content, and then let's load in our JavaScript file. Down here, I'll say app.script still here. Script pointing to app.js. Okay. So now we can save all. Let's copy the path of the index, and let's paste it right in our browser here. Okay, and when we run it, we can see that it runs the code in our JavaScript file. Okay, and so that's how we can compile with TypeScript. So now, let's go back to our TS file, and let's explore static typing in TypeScript. Okay, so static typing refers to declaring the type of a given piece of data before it's assigned a value. So let's go ahead. Let's explore how we can do data type or static typing with our JavaScript variables. So I'm going to declare a variable, and I'll call it my name. Okay, and because that's a string, I'm going to say colon string. Then I'm going to say equals. I'm going to say Joe. from here, let's go ahead and let's save all, and let's compile. So as you can see, that went through with no problem, right? Because this static type matched the value that was assigned to the variable, okay? However, if I was to take this value, maybe assign it a number instead, well now, watch what happens when we compile. So as you can see, we get an error, right? And it lets us know, hey, that's not assignable type of string. What's really great is this happens at compile time, not when the browser runs, so we can catch it before the end user ever has to experience that. Okay, so that's what static typing is, right? We're enforcing a type for a variable, okay? And just like we can do string, we can do other static types as well. So let's do a number type, okay? So I'm gonna say let my age colon number equals 99. So we save all, we compile, and we see that goes through successfully. Okay, so now let's set up a Boolean data type. Okay, so I'm going to say advance Boolean equals false. Okay, so as you can see, it's pretty simple process, right? You just put a colon and then the type after that. Compile. As we can see, it's successful again. So let's go ahead and let's do an object, or I'm sorry, an array. So let's say let, let's say friends equals array, and then we'll assign a type the array string. Oops, I should put colon instead of an equal sign. There we go. And then I can assign it Joe, Jack, Jane, and Jill. Okay, so we save all. Run this. You can see it runs successfully. Okay, and just know that your TypeScript code will still run if you don't assign it these static types. For example, if I save all here and don't assign it anything, well, it's going to run just fine because it's going to assign this the type of any. Okay, and so that's the best thing to do if you don't want to manually assign each and every type. If you just say any here, it'll allow you to assign any data type to friends. Okay, let's go ahead and run that, and as you can see, it runs successfully. Okay, so next, let's go ahead and let's talk about classes in TypeScript. Okay, so classes in TypeScript are just like they are, in regular JavaScript code, right? Made up, of three main factors. We've got our properties on the classes, which are variables with declared values. We've got our methods, which are function definitions in our class. And then we got constructors, which is a method that runs automatically when the class is initialized. So let's go ahead and explore each of these. Start off by creating a class, and we'll call this class greet. And as you notice, I name it uppercase by convention. Okay, and then I could put a property on here of greeting, type of string equal to hello world. Oops. Okay, and then I could add my constructor, which will run as soon as this is initialized, right? So what I'm going to do is I'm going to actually use the constructor to assign a value to greeting. Okay, so I'm going to say this to reference the class, then I'll say greeting equals hello world. Okay, and then finally we can set up our own custom method to console log that value. So I'm going to go ahead and say display greeting Okay, and then I will console log the value of this dot greeting. Okay, so now let's go ahead and create a new instance of this class. We'll say greeting1 equals, or greet1 equals new greet. And from here, we can go ahead and we can run the display greeting. So we'll say greet1.display greeting invoke. Okay, so we save all, and now let's compile with TypeScript. Okay, so that went through successfully. So we go back to our browser and we refresh, and as we can see, we're getting hello world printed out as a result of our method here. Okay, and yeah, that's how we can compile classes with TypeScript, and just like we would with regular JavaScript, except you'll notice for my properties, right, I'm actually giving them a static type. Okay, so next let's talk about class inheritance. Okay, so classes have the unique ability to inherit values from other classes. Okay, so let's go ahead and let's consider we have like a restaurant and we sell hamburgers and we sell cheeseburgers too. And the idea is the price of a cheeseburger is always $1 more than the price of a hamburger. So we should just be able to inherit the value from the hamburger price and add $1 for cheese. And that way we don't have to hard code it. So to see this in action, we could create a class called hamburger first. And this is going to have a custom method called getPrice, which will return the price of the hamburger, which we'll just say is 5 at this time. And we'll create another class. We'll call this cheeseburger. And we'll use the extends keyword to reference the hamburger as the base class. Okay, and so now using the super keyword, I have access to the base class characteristics. So, okay, now we can set up a getPrice method on cheeseburger, and we can return super.getPrice, which will return the value of 5. Then we can add $1 for cheese. So now we can create a new cheeseburger. And from here, we can console log the value of getPrice. All right. So we save all, and we refresh. Oops. Oh yeah. Oops. We gotta compile real quick. So let's do that. Compile. That goes through successfully. So now we refresh our browser. You can see we're getting the value of 6 because $5 hamburger plus $1 for cheese is 6. And now we can see, as the time goes on, maybe we increase the price of the hamburger. We never have to actually adjust the cheeseburger now because it's just going to adjust based on that hamburger. So we save that, we compile the new value in, then we go to our browser, and we refresh. We can see that it's taking, the value of the hamburger, which is 9, and adding $1 for cheese. Okay? And that's how we can work with inheritance. Okay? So, moving right along, let's talk about the TypeScript interface. Okay? So oftentimes we're going to want to enforce data structure within our classes, okay? Because they're going to be the blueprints which we're making all of our data from. So that being said, to enforce strict typing with classes, we can use an interface. So here's how it works. We simply say interface, and then we declare the name of the interface, which maybe I will just say is human. Okay, and human should have a name, which would be a string, and then human will have an age, which will be a number. Okay, and then when I create a class, let's say person, I use the extends keyword, or I'm sorry, not extends, implements keyword to implement the human interface for my person. So now what that means is the data structure of person must match the data structure of human, or I'll get an error. So what I'm going to do is I'm just going to leave this empty. I'm going to create a new instance of person. All right, so I'll say let person1 equals new person. Okay, and so from here, if we go ahead and we try to compile, it's going to give us an error because the interface is implementing, right? It doesn't match that data structure. So let's go ahead and see this in action. Save all, compile, and there we go. As you can see, it tells us class person incorrectly implements interface human. Property name is missing, right? So let's go ahead and let's add a name. Okay, oops, so we'll say name equals Joe. Okay, so we save all. And we compile again. And we can see here that we have a slightly different error, right? Age is missing now, right? Because we fixed name. So we can simply come in here and add age 99. Okay, we save all. And we compile again. And we can see we get through successful that time, right? Because person now matches the interface human in its data structure. And that's how we can work with interfaces in TypeScript. Next, let's learn how we can work with generics. Okay, so a generic is a function that will take in and work with any data type. Okay, so let's go ahead and explore this. We'll start off by creating a simple function. Let's say function, and we'll call it print line. And print line, we'll take in AT, and this is just the generic type. And then for our arguments, we'll have the type of T. Okay, so now let's console log the value of our arguments and return. So from here, we can pass in any data type. Okay, so let's go ahead and say print line. Okay, and then we'll go ahead and we'll pass in string, right? Because we're basically passing in the data type for this. And then for the argument, it needs to match that same data type. Okay, so I'm going to pass in Joe. Okay, so we save all. And we compile. We can see it goes through successfully, right? And now I can even take it one step further and I can change this out. So I can say, okay, now it's going to be a number, 99. Save all, compile. As you can see, compile successfully. So now, no matter what data type we pass in, it'll just adapt. And that's why it's called a generic. Alrighty, so let's go ahead and keep moving forward. Now let's go ahead and let's talk about a method decorator. Okay, so decorators are very common in Angular, and most of the time they're just built in for you. But it's important to understand, how they work under the hood. A method decorator is declared just before method declaration and can be used to observe, modify, or replace a method definition. So that being said, let's go ahead. Let's create a method decorator which will observe the outcome of an arithmetic operation, let's say addition. Okay, so what I'm going to do is I'm going to start off by creating a decorator called log equal to the following parameters. Okay, so method decorators take in 3 parameters. Okay, they take in the target, which is just going to be a string, and which is, you know, the, I'm sorry, no, this will be an object, and then the key will be a string. Oops. Object here, string here, descriptor, it's going to be the actual value, and so we're going to use what's called property descriptor for this, which will then return a value, which will be a function. This function will have a spread operator for our arguments, which will just have the type of any at this time. And then from here, we can log the outcome of our descriptor. Okay, so I'm going to say const result equals descriptor dot value dot apply. This apply method is going to target the target and use the arguments passed in. Okay, so from here, we can go ahead and we can console log the value of result and return it. Okay, so now we just need to set up a method to decorate. Okay, we have a decorator, but we haven't set up our method yet. So to do that, we're just going to set up a class, and I'll call this class calculator. Okay, and calculator is going to have an add method. Okay, and this add method is going to have parameter x equal to a number, parameter y equal to a number, and then from here we'll just return the value of x plus y. Okay, and so now to use this decorator, I simply need to use the @ symbol and reference log. Okay, so now it's going to observe this outcome, right? And I don't have to run all this console logic down in my add method. I can just observe it here in my log decorator. Okay, so let's go ahead and create a new instance of calculator. We'll say new calculator, and then we'll use the add method. We'll pass in 1 and 3. All right, so let's go ahead and save all, and let's compile. Yes, so as you can see, we have a warning like, so hey, it can't compile using the TSC command itself. We actually have to use a special command to compile decorators. Okay, and that's because they're considered experimental at this stage. So what we need to type instead is the following. We need to say TSC -- target ES5 -- experimental decorators. And then we're going to target AppTS. Okay, so as you can see, that time it compiled successfully. So now we can refresh. You can see we're getting the value of 4. And that's because 1 + 3 is 4. And you'll notice, we didn't have any console log, nothing like that stated down here, right? It all took place here. And we just needed to declare right before that method. Okay, and that's what's called a method decorator. Next, let's learn about a class decorator. Okay, so class decorator is similar, except instead of declaring it before a method, we declare the decorator before a class. And in that same way, we can use it to observe, modify, or replace a class definition. So let's go ahead and let's use a decorator to override our constructor value when a class initializes. So let's go ahead and get rid of our old decorator. And we'll create a new class called or a new function called class decorator. And this is going to take in generic type of t, use the extends keyword on a new. We'll pass in spread operator of arguments, which will take in the type of any. Okay. Here we'll pull a colon or an empty bracket. Okay, from here we will place a ending arrow bracket here, and we will take in the constructor. The value will be t. Okay, and again, that's just a generic value, right? All right, so next, if we want to override the values of a class constructor, we need to then return the class extends constructor, at which time we can assign a new property to the class, and we'll just call it our new property. And then we can set up a hello, and we'll use this to override the initial hello that is assigned. Okay, so from here, let's go ahead and set up our class, and we'll call this class our greeter class. Okay, and inside of our greeter class, we're going to assign a property, the value of some property. And then from here, we will set up hello as just a standard string. Just put that here too. Okay. Then we'll set up our constructor, which will take in a new value. That'll be a string. Oops. And then from there, we can go ahead and we can take the value of hello and overwrite it. So we can say this dot hello equals m. Okay, and then from here we can just console log new greeter, and I'll pass in world. So we can add those on there. Okay, so we save all. And we use our special compile command. Nope. Looks like my line 5, I gotta. Oh, yeah, I never put an equal sign there. Okay, so save all. Let's try that again. Cannot find name ML. Oops. Let's see here. ML. Nope. Looks like I should have just put M. Okay. Third time's a charm. All right. And that time it went through. Okay. So if we refresh, we can see that we get the new greeter instance, and it takes the value that's passed in world, right, and it uses it to overwrite the hello property, right? And then it assigns this property as standard. Okay, and so from here we can use it as a decorator. Okay, so I'm going to go ahead and I'm going to say at class decorator. Okay, and then we'll save all. Refresh again, and as you can see, oh, actually, we need to compile real quick. And then when we refresh, we can see now it overrides that property, right, using this class decorator. All righty, so let's go ahead and let's open up the floor. Let's see if anyone has any questions so far. The floor is open. If you have questions, feel free to ask those now. Okay, so I don't hear anything so far, so let's go and move on to the topic of Angular. Okay, so first thing you should know about Angular is it has a couple of different versions, okay? And today we're going to be learning the newer version of Angular, okay? The newer version of Angular is built all around a command line tool. So if you don't have the Angular CLI tool, you'll need to come and install it here. And once you've installed the Angular command line tool, we can then scaffold together a new Angular app. So how I'm going to do this is on my desktop here, I'm going to go ahead and say ng new, and then I'll just call it my app. Okay, great. So we'll go ahead, change directories into my app, and then let's go ahead and open it up inside of our text editor here. Okay. So let's go ahead and talk about what's going on here in the starter kit. Okay. So up here we got E2E, that's just testing. We don't have to worry about that right now. Next we got node modules. These are all the dependencies, libraries, frameworks, right? All that stored in here for us. Our source code is where our main client-side logic lies and how we're going to be building out our browser app. Okay, and then all these packages here, you see Angular CLI.json, Karma config package, right? All these are just configuration files, and you really don't need to mess with any of those at this time, okay? Really, all of our attention should be in the source folder. Okay, so that being said, if we look at the package.json, we can see that they have a script command. If we run start, it's going to serve this in development for us. So let's go ahead and let's run this app in development. Okay, so I'm going to go ahead and I will say npm start. Okay, so as you can see, it's running at localhost 4200. Let's go ahead and navigate there. There we go. So as you can see, we have a basic Angular app up and running. And so let's go ahead and go over how this is configured. So what we've got inside the app folder is our main app module. And there's a basic 3-tiered architecture to Angular. Okay, so we've got what's called the main app module. And that's the first tier. And every Angular app has to have at least one main app module. Okay, it's like the center of the solar system, right? Like the sun. And everything revolves around the main app module. Okay, and then we've got a second tier called the component. And a component is responsible for all of the rendering logic, as well as the page interactions like button click events and so forth. And then we've got the third tier of the Angular architecture, which is called the service. The service is responsible for sharing logic between components and communicating with third-party resources as the business layer. Okay, so let's go and start off by looking at the main app module. So as we can see here, we go app.module.ts. they have set up the main app module for us. And as you notice, they're using these built-in decorators, right? We don't have to build these ourselves. Angular just does it for us. Okay, so you notice we've got to declare our app component as the main component and bootstrap that one. Okay, and then here in our HTML is what we're seeing rendered, right, as the markup here. Okay, so now we've set up a basic Angular app. We want to bring in components, right, because those are responsible for all of our rendering logic. So let's say today we want to render a to-do list. So I'm going to create a to-dos component. And how I'm going to do this is using the Angular command line tool. So let's go ahead and run the command ng generate component. And then we'll name the component to-dos. Okay, so as you can see, it's imported a to-dos directory inside of our main app module. And you'll notice this is a very similar structure to our main app module, right? It's got style sheets, HTML, all that good stuff. Okay, so this to-dos component is going to be nested inside of our main app module. Okay, so let's go ahead and first go to our to-dos component. Yes, and this is where all of our application logic lies. Okay, so the selector is going to be the HTML element, which renders our HTML file for to-dos component. So what I'm going to do is within our to-dos class, I'm going to store some to-dos in a property field. Okay, so I'll just do it like this. I'll say to-dos array string, which equals workout, go to store, make dinner. Okay, so we got our to-dos being loaded in on the component here. So what we can do in to-dos component.html is we can reference those and loop through them using what's called an ng-for directive. Okay, so what I'm going to do is create an unordered list, and then a list item, and I'm going to set an ng-for directive. Okay, and how ng-for works is I've got to specify a variable to represent each element in an array. So I'm going to say ng-for let t of to-dos. Now t represents each to-do. I can use what's called a template string to output that. Okay, because this is going to bind the data from our to-dos component TS, which is known as two-way data binding through Angular. So from here we can say all. Next, we need to nest our to-dos component within our app component. And how we're going to do that is we're going to reference the to-dos component HTML. Okay, and as you can see, our selector is called app to-dos. So within the app.component.html, we need to set up an element called app to-dos. Okay. So from here, we can save all. And let's run this again in our browser. Okay, let's head back, let's refresh, and as you can see, using our component, we are rendering the to-dos. Okay, and you'll also notice those weren't hard-coded, right, in the list. They were looped through, referencing this to-dos component here. Okay, and so now we've seen how to interact with our rendering logic using the component. Let's learn how we can now bring in a service to share the logic of getting all the to-dos between our components, so we don't have to repeat ourselves. So create a service is similar to how we create a component. We just come to our command line and we say ng generate, and we say service. The service will be called todos. Okay, so as you notice, it doesn't import a directory, it just imports a to-do service. Okay, so the idea here is I'm going to go ahead and I'm going to reference the to-dos in my to-dos component, and I'm going to reference those inside my service instead. Okay, so I'm just going to go ahead and get rid of this here. And then within my to-do service, I'm going to go ahead and set up a method to return my to-dos. Okay, so let's head over to our main .ts module, and let's bring in our service. So we'll say, oops, let's do it down here actually. Import to-dos service from to-dos dot service. Oops. Okay, and then we just need to take to-dos component, or I'm sorry, to-do service, and we'll pass this in the providers field here like so. Okay. So now we've set that up, back in our to-do service, we can go ahead and we can set up a get to-dos method. And the get to-dos method is going to have our to-dos. Let's just say our to-dos are to wash the car, mow the lawn, and paint the fence. Okay, and then we will return the to-dos as the result. Okay. So from here, inside of our to-dos component TS, we can import the to-do service. So I'm going to say import to-dos service from to-dos dot service. And then within my constructor field here, I can go ahead and I can inject that. Okay, so I'll say private to-dos service equals the to-do service. Oops. Okay, so now in my constructor field, I can assign the value of my components to-dos to the to-dos that are returned. So I'm going to go ahead and I will say to-dos, give that type of any, and then I'm going to say this dot to-dos equals to-dos service dot get to-dos. Okay. So let's save this and let's open our browser. Oh, looks like I have a typo somewhere. So app module TS, let's go there. So let's see here. Yeah, it looks like I misspelled to-do service. There we go. Say all. Let's run that again. Okay, went through successfully that time. Let's go ahead and refresh. Okay, and as you can see, when the browser loads in, the component, the to-dos component, references the to-dos service get-to-dos method and assigns that value to to-dos. Then the to-dos service runs and returns the array, at which time we loop through it and display those to-dos. Okay, and now we have a to-do service. If we have other components, maybe a home component, about component, whatever, we can import that to-do service multiple times and inject it here in a constructor instead of having to repeat that to-do service logic over and over again in the component. Okay, so this is what we mean when we say shared logic. The service is shared between all the components. Okay, so let's wrap up with the topic of observables. Okay, so observables is simply a collection that arrives over time. Normally, when you're requesting data from like a third-party server, sometimes it takes a few seconds. So, if you know it's going to be delayed, use an observable, and that way we can subscribe to that observable and return the data once it's available. So let's go ahead and set up an observable inside of our service. Okay, so I'm going to go ahead and head over to our to-do service. I'm going to start by importing an observable. Okay, so we'll start off by saying import observable from RxJS slash observable. Okay, so now we got that set up. Within our get-to-dos method here, I'm actually going to get-to-dos, a new observable, which produces the observable object. And the observable object has a next and a complete method. And the next method is how we're going to run the subscribe callback, and then the complete will finish the operation. Okay, so I'm going to go ahead. Oops, I called it the same thing. It should be observer. The observer object has those values on it. Okay, so I'm going to observe, and then I'll pass in the following to-dos. I'll say feed the cat, walk the dog, and clean the kitchen. Okay, so after this, we'll set up the complete method, complete the observable. And now we need to set up a subscribe method inside of our component. So inside to-dos component TS, what I'm going to do is I'm going to set up a to-do service. Okay, so we'll say this dot to-dos service dot get to-dos. And because get to-dos is an observable, I can then use the subscribe method. Subscribe method will run when the next function is ran. Okay, and as we see, the next function is ran as soon as the get to-dos method is ran. Right, and so that way it will return the data. Okay, so let's go ahead and take the data that's returned, and let's use it to display the to-dos. Okay, so I'm going to say this dot to-dos equals the data. Okay, so let's go ahead and save all. Let it refresh. And there we go. We have the array being returned from the service and rendered using the component. Okay, and once again, that's called an observable, and it's used when a collection arrives over time. So let's go ahead and open up the floor and see if anyone has any last questions today. So the floor is open. If you have questions, feel free to ask them now. All right, I don't hear anyone. Going once, going twice. All right, we're out of here. Thanks everyone for stopping by. Have a great day and happy coding.